Our current understanding of physics breaks down at the singularity. The equations of general relativity themselves become undefined. Surrounding this singularity is the event horizon, a spherical boundary defined by the point of no return. The gravitational pull within this boundary is so intense that the escape velocity exceeds the speed of light. Anything crossing the event horizon, including light itself, is trapped forever and cannot communicate with the outside universe. The size of the event horizon is directly proportional to the black hole's mass. For a long time, black holes were primarily conceptualized as cosmic sinks, regions of space-time with gravity so intense that nothing could escape. A one-way ticket to oblivion for any matter or radiation that ventured too close. They were seen as the ultimate destroyers, consuming stars, gas clouds, and even other black holes. However, recent theoretical investigations, driven by attempts to reconcile general relativity with quantum mechanics, have opened up more speculative avenues. One compelling idea posits that the singularity at the heart of a black hole could represent not an absolute end, but rather a transition to a new space-time, a new universe with its own unique properties, potentially existing in a different dimension or with different fundamental constants. This concept finds resonance with our understanding of the Big Bang, the prevailing cosmological model for the origin of our universe. The Big Bang describes an expansion of space-time from an incredibly hot, dense state approximately 13.8 billion years ago. Some theorists have drawn parallels between the initial singularity of the Big Bang and the singularity within a black hole. Could the extreme conditions within a black hole's singularity somehow replicate or trigger a similar expansion, giving rise to a new independent cosmos with its own arrow of time and set of physical laws? This idea suggests a cyclical or branching model of the universe, where black holes in one universe could be the seeds of new universes. One theoretical construct that supports this notion is the concept of a white hole. Unlike black holes that only allow inward passage of matter and energy, white holes are theorized to exclusively expel matter and energy. While no white holes have ever been observed, their existence is mathematically permissible within the framework of general relativity. Some physicists hypothesize a connection, possibly through a wormhole or some. Furthermore, the extreme curvature of space-time within a black hole, particularly a rotating black hole described by the Kerr metric, might lead to a topological shift. In such scenarios, the singularity is not a single point, but a ring, and it's theoretically possible to pass through this ring into another region of space-time without being crushed. This other region could be another part of our own universe, a different time, or even a completely separate universe with its own unique characteristics and physical laws. This idea often intersects with the challenging domain of quantum gravity, a theoretical framework attempting to reconcile general relativity, which governs the large-scale structure of the universe, with the principles of quantum mechanics, which governs the microscopic world of particles. A successful theory of quantum gravity might provide a more complete understanding of the singularity. The implications of such a scenario are profound and far-reaching. If black holes are indeed capable of generating new universes, then it's conceivable that our own universe exists within the interior of a black hole, residing in a higher dimensional space. The observed expansion of our cosmos, the cosmic microwave background radiation, and other large-scale features might be explained by the internal dynamics of this parent black hole. This perspective offers a completely different. This perspective fundamentally alters our understanding of cosmic origins and the nature of reality itself. Are the black holes we observe throughout our universe not merely destructive forces, the tombstones of dead stars, but rather the potential seeds of countless other universes, each governed by its own unique physical constants and laws? Could the fundamental constants that define our universe, the speed of light, the gravitational constant, the masses of elementary particles, be just one set of possibilities among an infinite range, with each black hole potentially creating a universe with a different combination? This opens up the tantalizing possibility of a vast multiverse where our universe is just one instant. While these ideas remain firmly in the realm of theoretical physics, often at the forefront of research in areas like string theory, loop quantum gravity, and other attempts to unify our understanding of the fundamental forces, they serve as powerful catalysts for scientific inquiry and imagination. They invite us to consider the possibility of a multiverse where our universe is but one instantiation among a potentially infinite number, each perhaps born from the collapse of a massive star in a preceding cosmos. As our exploration of black holes and the universe continues, through increasingly sophisticated telescopes and theoretical models, these intriguing possibilities underscore the limits of our current knowledge. The answers to some of the most fundamental questions about existence, about the origin and fate of the universe, and about the possibility of other realities may lie hidden within these enigmatic cosmic objects, waiting to be uncovered by future generations of scientists.